Hey everyone, today we're going to be going over acid-base reactions. Now acids and bases may seem a little bit tricky sometimes, but it really just follows a simple pattern each and every time. The only other thing that we really need to worry about is just a little bit about definitions, okay? So let's go through some basic definitions so that later when we do these practice problems, we know what we're referring to. So we have two things. We have an acid and then we have a base, okay? So there's a couple different definitions of an acid, but one of them states that an acid is something that likes to donate protons, okay? So usually you find an acid that has, protons associated with it, usually a hydrogen, and after the reaction, it will donate its hydrogen. So after the reaction, the acid will be left naked and won't have a hydrogen, okay? And then the base is whatever picks up that proton. It accepts. It's a proton acceptor, okay? So pretty much an acid gives up a hydrogen and a base accepts the hydrogen. And everything else has to shift to compensate for that, okay? So usually when you get a question, the first thing we identify is the acid and the other thing, which is the base. So this one would be the base, okay? And then the reaction happens. And then on the other side, they're no longer called acids and bases. They're called conjugate acids and conjugate bases. Basically, it just means this is what we have after the reaction, okay? So if something is an acid, its counterpart will be the conjugate base, okay? And the base, its counterpart will be the conjugate acid, okay? So always just remember that. It's a little bit crisscross. But that's pretty much all we need to know. Everything other than that is a little bit too much, but just simplify it and let's go through a couple examples. Okay? So let's see if you can see this pattern over and over again. So how about we draw this molecule right here. Here's a nice little benzene ring. Double bonds. Okay? And then double bonded oxygen, and then another oxygen here, and this one has a hydrogen attached to it, okay? And just a little trick, when I do acid-base reactions, I always like to draw in the electrons. It always helps me keep track, and when you're doing formal charge, it also helps to keep track as well, okay? So if you need to brush up on formal charge, I would definitely do that, because with acids and bases, you definitely look at that a lot, okay? If we look at these oxygens right here, they both have 6 things around them, so they both have nothing for a formal charge, which is good, okay? So here's one thing, and other part of the reaction is going to be this guy. What if I gave you, we're drawing blue. Well, actually, we'll keep it in red. So what if I gave you an NH3? Now, you can draw the hydrogens coming out and stuff, but this is really just the simple part, okay? And we know this is like that. And then 2 electrons right here. So this guy would have no formal charge as well, okay? And then we know after something happens with the reaction. And the question is, what happens within our acid-base reaction and what products are formed? Okay, and I'll draw this as double arrow right now and we'll get back to it later. So, remember what we said. The first thing we want to do is identify what's our acid and what's our base. And then we can kind of follow along that pattern. So here, how about we draw this? This guy is going to be our acid. And then this guy is going to be our base. Now the more questions you do, you'll usually be able to identify common acids and common bases. But this guy has a hydrogen that it wants to give up, and this guy is going to accept it. Usually NH3 is going to be a base, or something like that. So, what's the pattern we see? Well, remember, an acid is a proton donor. So this one, pretty much, when you donate a proton, you loses a proton, or loses its H, okay? So this H right here, we somehow have to lose it, and this base somehow has to pick it up. But we have to show that. Well, basically what happens is that this bond between the oxygen and the hydrogen breaks, okay, and turns into electrons, right? So if a bond breaks, it can't just disappear. It has to become something else. You can't just let it go. So the bond breaks and becomes electrons around the oxygen. And now the hydrogen is free to leave. And what happens is the base sees that, puts out its electrons, and grabs the hydrogen, okay? So these are really the only two arrows that we need to see. A bond breaking and becoming electrons. Now the hydrogen is free, so the NH3 is going to come up and grab that hydrogen so that it can form a bond. Okay? That's really all we need to know. Now, what are the products that we form? Well, we have that, I'll draw it nice and small. We have this guy, still stays the same. We have our oxygen here, still stays the same. And then we have our oxygen here. And remember what happened? The hydrogen left, and this bond was broken. So now we have our 2 electrons that we had before, and since this bond is broken, now we have 2 extra electrons. Okay? Now look at the formal charge of this oxygen. It's no longer neutral. It's now 6 minus 7, right, for a formal charge. So now it has a formal charge of -1. So we always want to put that in. And what's the other product? Oh, sorry, we'll use this one. What's the other product that gets made? Well, remember what happened to the hydrogen? The hydrogen got kidnapped by the ammonia. So now this became NH4, NH4, and this one is positive. And remember, if we want to label the rest, well, this was acid, so this becomes a conjugate base. This was the base, so this becomes a conjugate acid. Remember, it's backwards a little bit. But that's pretty much all we need to know. So this bond broke, became extra electrons, and the hydrogen got kidnapped and went to the base. So that's how we show an acid losing the hydrogen and the hydrogen going to the base. If we look over here, that's exactly what happened. Between this guy and this guy, the only difference is that a hydrogen was lost and the formal charge was changed. In this guy and this guy, a hydrogen was gained, right, because the base is a proton acceptor, so hydrogen was gained and the formal charge was changed. But if we look at the formal charge on the left-hand side and the right-hand side, they're both equal. This has a neutral, the reactants have a neutral formal charge, and the products have a neutral formal charge overall, a -1 and +1. It gives you a neutral formal charge overall. So that's how we know we did it right. So that's very nice. The only other thing that we can look at is this double arrow right here. Sometimes reactants are favored, sometimes their products are favored. So if the teacher asks you to go further, this is what you can do. Okay? So we can write the pKa values. So the pKa values can sometimes be found on a table, or they may be given to you. But remember, pKa values are only for acids and conjugate acids, right? So if you see something like an acid or a conjugate acid, remember you can assign a pKa. So this guy has a pKa of 9.95, approximately. And this guy has a pKa, remember acids only, and conjugate acids, pKa of 9.25. Now, a nice simple trick for which side is favored. Honestly, just look at which one has the higher pKa. Reactants have a higher pKa, so I already know my reactants are favored. But if your teacher asks you to show that, well, this is really kind of the reasoning behind it. Basically what happens is that KEQ equals 10 to the power of our conjugate acid minus the pKa of the conjugate acid minus the pKa of the acid itself. So it would be 9.25 minus 9.95, or negative 0.1.25 minus 9.95 is negative 0.7, right? And if you did the math on that, you'd find that it's a very small number. Okay? So you find it's a very small number, so it's less than 1, right? And as the rule goes, if our pKa is less than 1, then the reactants are favored. So, but, I mean, we already knew that because higher pKa, usually side that's favored. So we can tell that the reactants are favored. Reactants are favored. And if we want to draw this a little bit more accurately, this guy is a little bit bigger, and this guy is a little bit smaller. And since reactants are favored, this one is more likely to happen in this direction, okay, going backwards towards the reactants. So that's really all it is with acids and bases. The acid loses a hydrogen, and the base picks it up. And then we draw the products. And the formal charges will change, but the overall formal charge will stay the same. We have our acid, we have our base, we have our conjugate base, and our conjugate acid. And if the teacher asks you to go further, you can use the pKa's to find which side is favored more. And remember, make sure you show the arrows going in the right places. Hope you see the pattern and check out more videos. Thanks.